Welcome class sa second lesson natin sa Earth Science. In this video, I will talk about the Earth's hot interior. The question that we want to answer in this lesson is kung saan nga ba galing ang heat or what is the source of the Earth's internal heat. What we know is that the Earth's internal heat provides the energy for our dynamic planet. Nagkakaroon ng movement ng plate tectonic or kaya naman earthquakes and volcanic eruptions because of the Earth's internal heat. But the question is again, where does this heat came from? Scientists have identified two main sources of the Earth's heat. First is the primordial heat. So this heat resulted from the processes that happened during the Earth's formation, meaning to say, the primordial heat existed or is caused by the formation of our planet 4 billion years ago, and this is a result of the clumping together of different materials. So this primordial heat involves accretion energy, adiabatic compression, core formation, and the decay of short-lived isotopes. Aside from primordial heat, 50% of the heat ng planeta natin is coming from the decay of long-lived isotopes. So this involves potassium-40, thorium-232, uranium-235, and 238. Isa-isahin natin ang sources of primordial heat. First is accretion energy. Now, first, accretion is defined as the process of growth or enlargement by a gradual build-up. So it is known that our planet started as a cloud of gas and dust, and as these materials clump together during the formation of our planet, they produce heat. So the heat production continuously happen until the Earth is formed. So yung init caused by accretion can be simply compared in the heat produced as we hammer down a nail. Yung pako, pag pinukpok mo ng paulit-ulit, produces heat. Uh, Pag hinawakan mo, mainit na yung ulo ng pako. This is because of the transfer of energy from potential to kinetic energy. Next is adiabatic process. So this is defined as the process where no exchange of heat is happening from the system to its surroundings. So kung kanina na-produce ang heat during accretion, ang adiabatic compression naman ang reason why the Earth's primordial heat is still existing. This process ensures that no heat will escape from the Earth's interior, lalong-lalo na during the early years of our planet kung saan wala pang movement, wala pang dynamics happening sa layers ng planet natin. Next is core formation. So the formation of our planet did not end with the accretion of materials. After the accretion, nagkaroon ng differentiation of materials. Sa madaling sabi, yung mga materials na magkakaparehas ng characteristics will join together. This is what happened during the formation of our crust or our core. So the dense materials sink to the center of our planet, forming our core, and the lighter materials floated on top of it, forming the mantle and the crust. Well, of course, habang nagsasama-sama ang mga materials na to, accretion energy is produced, which in turn causes heat. Last, under primordial heat, is the decay of short-lived isotopes. This is caused by the radioactivity of aluminum-26, uranium-236, lead-205, and other uh, short-lived isotopes. So ito yung mga elements na napoproduce during the early formation of a celestial body, of any celestial body. It could be a planet, an asteroid, or a star. And their radioactivity will cause heat. And since they are short lived, these elements are no longer existing in our planet. We only know that they have been the source of primordial heat dahil sa mga end products na present pa ngayon sa planeta natin. And of course, as we study other celestial bodies. Now, we have enumerated the different sources of primordial heat. Now, let's go with the decay of long-lived radioisotopes. So, it is said that 50% of the Earth's internal heat is caused by this. And this involves the decay of potassium-40, uranium-235, thorium-232, and uranium-238. Now, let us look on the distribution on Earth's internal heat. So, heat is transferred through the different layers of our planet by conduction and convection. And of course, kung merong local radioisotope dito, maaari ding merong radiation. So, in different layers, maaari may radioisotope dyan, dito, or anywhere else, maaari merong radiation that is happening. Now, I want to point out that the heat transfer from inner core to outer core is caused by conduction. Now, within the outer core, meron namang convection. This convection caused the presence of magnetic field sa planeta natin dahil meron ngang paggalaw dito ng materials because of convection. Another thing, yung pinakasikat, the convection happening in our mantle. Yung convection na yan caused the movement of plates na meron dito sa ating Earth's surface. And heat is transferred from the mantle going to the crust because of conduction, which causes different tectonic activities like volcanic eruption. On the other side naman of this picture, you can see the geothermal gradient. Ang geothermal gradient, sinasabi lang nito na as you go deeper from the crust to the core, tumataas ang temperature ng ating planeta. However, hindi directly proportionate ang pagbaba ng kilometers going underground at ang pagtaas ng temperature. So as you can see there, may curve, may mga times na flat yung pagbabago ng temperature or very minimal yung pagbabago ng temperature. So we call this as non-linear. Kasi kapag linear, we can say na diretso, as you go deeper, the temperature increases directly proportionate. So, yun ang geothermal, or this is what you called as the geothermal gradient. Now, we will continue discussing the Earth's heat and its connection to magma sa next video. Thank you.